That's someone else. Okay, so suppose, optimization, okay, part 3 here. Suppose that 600 feet of fencing.
0 to 100 real quick.
I don't know, because it lends itself to perimeters and areas and things. So. Is used, and this actually may benefit Ryan, who is having difficulty with one of those semicircle problems. So, is used to enclose. Okay, enclose a corral in the shape. I think that's how you spell corral. Anyone? In the shape of a rectangle.
Good stuff. Let's do golden corral and shell. No, let's don't. Why do I feel like golden corral is Caleb's dad's favorite place to eat?
No, my dad's pretty. Place to eat is going to Costco and getting golden
Alright, in the shape of a rectangle with a semicircle whose diameter is the side of the rectangle.
Well, it's not. What? It just doesn't make sense because if you make a semicircle the side of a rectangle, it's no longer a rectangle.
It's a rectangle with a semicircle attached to it.
It's like a rectangle and then like this.
Yeah.
Yes.
Like
If I get it, you can.
Now, Mac.
Burn yourself.
Boy. Give yourself more credit,
gosh.
and give Ryan a chance. Sometimes everyone has trouble with getting pictures.
I can see it. I can picture it in my head.
All right. Find the dimensions of the corral.
I'm so ready to optimize this problem.
Okay, of the corral with maximum area.
Are they always going to do like find the dimensions?
Sometimes it could be, find the maximum area of the corral. So, in this case, though, we're just finding the dimensions first. But then once we have those dimensions, we'll be able to find the maximum area. A capital C?
Where?
Doesn't look like it says lowercase.
So, optimization is basically for...
All right, guys, so let me talk, and then you can listen, all right, and ask questions. All right, hang on, all right. So we're going to draw a picture here first, right? Suppose that 600 feet of fencing is used to enclose a corral in the shape of a rectangle with a semicircle whose diameter is the side of the rectangle, okay? And so, yes, Mac's description was correct, all right? We're going to draw like a little rectangle here, okay? I'm going to draw a dashed line because that's not going to be fenced, right? Because we have this semicircle dealy thing going on right there. Perfect. Just like you dreamt.
So do we count that area inside the semicircle as part of the maximum area?
So yes is the answer. Yes, the corral, right, is fenced off on these 3 sides of the rectangle, and then the 4th side of the rectangle is not a rectangle; it's a semicircle. Okay, piece there. Okay, so that's the idea. Okay. Or it could approximate, yeah. Okay. So, we're trying to maximize the area, so our primary equation is going to be...
X, Y...
No.
Oh, no, yeah.
Oh, so we're not given a radius?
Right. We're not given a radius here. So we want to find the primary equation. Primary equation is going to be our area, so we have to come up with an area formula for this shape.
X, Y times 1/2 pi r squared
times xy.
So let's start labeling some things here. Well, the rectangle's got pretty easy dimensions. We can just label that like x there, right, and like a y there. And so the area of the rectangle, that's easy. What is that?
XY.
Just xy, right? Okay, but then to that we have to add the area of the circle. Now, what's the area formula for a circle? Pi r squared. But since this is a semicircle, 1/2 pi r squared. Okay, now this is kind of problematic. We have 3 variables here. But this r, instead of using the radius, it's 1/2 x. Exactly right, because x is actually the diameter of that semicircle, right? So 1/2 that x would be the radius. And so we can say that a really is equal to xy plus 1/2 pi times 1/2 x quantity squared. Okay, or x over 2 if you want to say it that way.
Is it X?
So, sorry?
What happens in the all?
So that is the 1/2 x,
Okay.
right? Do you understand why that is?
Yeah, no, I
Okay.
just didn't,
Yeah.
I get it now.
We substituted it in. Because again, the problem was we had 3 variables. We really want to try and reduce this down to 1 variable. Even still, though, we still have 1, 2 variables here. We have x's and y's, okay? And so that's a problem. So since there are 2 variables in our primary equation, 2 independent variables, what do we need to go to now? Yeah, a secondary equation. Okay? And what is our secondary equation going to be? Yeah, the perimeter. And so we already know the perimeter is 600. That's how much fencing we have to use. Okay? And it's going to equal. Now, let's do the easy part. What's the perimeter of the rectangle going to be? Yeah, x plus 2y's, right? Even though the other one's not labeled, we still have to include it there. So it's x plus 2y. But then we also have to add this part of the circle.
Let's call it Z.
So yeah, what is this? 1/2 pi times the diameter, right? Because what's pi d? Circumference, right? Isn't that circumference? It's half the circumference of the circle. The perimeter of the circle is what we call the circumference of the circle. So yes, we want 1/2 of that, so it's 1/2 pi times the diameter. What's the diameter of the circle? X, which is 1/2 pi x.
So we just, okay.
1/2 pi x.
Or pi x over 2.
Pi x over 2, or pi over 2x. I mean, yeah, there's a lot of different ways you can write that. Okay. So yeah, so there that is. Ugh. Which variable then should we solve for here? I would say, yeah, y, okay? I mean, they're both kind of yucky, but I'd say probably for the y here. So 600 minus x minus 1/2 pi x equals 2y. So we subtract over the x terms. And then divide through by 2, right? And so I get that y equals, let's see, 300 minus 1/2 x minus 1/4 pi x, right? We divide all those terms by 2.
This is going to be fun.
Right.
Imagine some farmer doing this. Like,
Right.
600 biggest fan. Like in Corral. Trying to find the primary thing.
There you go. That's right.
Should have made a rectangular one.
That's why we're going to have agricultural engineers, right? And they'll figure it out. No, I don't know. Yeah, I'm sure farmers do it in a much more efficient and
I'm sure they just go, well, here, let's
quick way.
do it this way.
And then start building one.
well, I ran out of fence.
Actually, they would probably
Crap.
figure out how much area they needed and then buy the fence.
Or just measure it off, yeah, in the first place. Or doesn't care about maximizing it either. It's like, I made it good enough.
I don't care about PETA. I'll
Right.
shove all my farms, all my cows into the tiny little...
So this whole thing gets substituted in for the y right here. So we end up with a equals x times the quantity, 300 minus 1/2 x minus 1/4 pi x plus 1/2 pi 1/2 x quantity squared. Woof. Okay, that is messy.
You can take the derivative of that?
Not yet. We're going to simplify it first, and then take the derivative.
I was going to say, this is starting to look like one of those old
Right, yes.
age problems.
Right, have we taken the derivative yet? No. All right, we're going to simplify it. That's algebra 2, okay, or pre-calculus, you want to say, but algebra 2. All right, or algebra, really, right? So it's like algebra we're going to do first, then we'll get to the calculus part. So right now,
An algebra student told them to simplify it.
no real calculus yet, okay? All right, well, let's distribute this x. I'm going to make this, instead of 1/4 pi, I'm going to start writing that as pi over 4 now. Pi over 4 x squared. Okay, so the x distributes. Whoop, 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 like that. Now, I'm also going to simplify this 1/2 pi times 1/2 x squared. So 1/2, the quantity 1/2 x squared, that becomes 1/4 x squared. But then it's 1/4 times 1/2, so it's really going to be 1/8 pi x squared. And I'm eventually going to make that pi over 8 x squared too, because I can. Okay. So again, that was algebra. Notice I didn't write, I left this blank, right? But it's assuming back up to the original, that's still a that we're equaling here. But now at this point, what do? Take the derivative. So I'm going to write a prime here, which is what you all should do. I don't want to see just an equal sign here. You should write a prime now to indicate you're taking the derivative here at this step. Okay? A prime equals, and that gives us 300 minus, oh, that's nice, x. Okay? Pi over 4 times 2
Is pi over 2.
Yeah, 2 pi over 4, which implies pi over 2, x. And then 1/8 pi x squared, well, the 2 multiplies out front, so it's 2 over 8, 1/4. And I'm going to make that pi over 4 x then. Okay, so there's that. All right, great. We've taken the derivative. Now what?
Set it equal to 0.
Set it equal to 0.
Would this be a calculator problem?
Right now, we haven't needed a calculator yet.
The pies scare me.
Yeah, I love finding.
I just want the...
Okay.
What are we gonna do with pi?
You have common sense.
So we do have some common terms here. I'm going to subtract over the 300 though, so I'll do that. And that gives us negative x, negative pi. I should have added these over actually now that I'm looking at this. Oh well.
Oh, well, combine them.
Yeah. Okay. And again, we're trying to solve for x here. So now that I've subtracted that 300 over, what can we do now? Yeah, I can factor out an x. Okay, these all have an x in common here. So I have x, and then I'm left with negative 1 minus pi over 2 plus pi over 4.
And that's simplified as negative 1 minus pi over 4.
We could do that. I'm actually not going to bother simplifying that. What I'm going to do instead is just divide that thing over. Divide negative 1 minus pi over 2 plus pi over 4. Divide this whole quantity over here to the negative 300. So I get x equals negative 300 over like that.
I like it.
Okay? So there it is without a calculator. Of course, with a calculator, though, to make it nice. Well, not nice, but to get a number at least, so that we don't have to worry about trying to plug that back in and see if it's like...
The farmer goes in the store and says, "Need negative 300 divided by negative 1 minus pi over 2 plus pi over 4 fence."
Actually, this would be more like he tells his farmhand that he needs him to measure off that length of for the corral. He already has the 600 feet of fencing. He needs to measure that off. And the farmhand would be like, what?
Anybody get... I got 168, but I think I might have done it wrong.
That's what I got when I inputted this.
I think you need to use more than one parenthesis.
168.
Oh, okay.
Boom. There it is. Okay, 168 is what you should get there, okay? Make sure you can type that stuff in your calculator accurately, because if you don't, then all that work you did was for naught. All right. Well, not for naught, but you wouldn't get full credit. Okay. Yeah.
Is it the same if we like actually like
Say again what you do. It would not be exactly the same, no, because the pi button on the calculator is more accurate than 3.14. So, I think it does 7 or 8 or 9. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Hey, Mr. Wood,
Yeah.
I did it a different way. I combined all
The pi's.
the x's together,
Okay.
and I got a different answer when I input it. I don't know exactly where.
All right, I'll take a look at it in a second here. Shh. All right, folks. Focus in here. We're not done yet. All right, so we found x, but we still have to find what? Y. So we go up to our old secondary equation here that we have, and we know that y is equal to 300 minus 1/2, and then for the x, we're going to type in 168.030 minus 1/4 pi times, again, 168.030. Okay. The secondary equation that related the x and the y in the very first place. Okay. And it's nice because it's already in. Y equals stuff with x's over here. So you plug in the x's, you'll get what y is. So we just got to type this mess into our calculator here. So 300 minus 0.5, 168.030. Oh, would be helpful if I did that. There we go. Okay, 168.030 minus 0.25 times pi times 168.030. And we should get 84.01. I'm going to say 5 because that's going to round up there. Okay. If you need to, don't try and do this maybe all in one group. Do it a piece at a time. So just do the 1/4 pi, 168.030, do the 1/2 times 168.030, and then do the subtractions. Okay. Because it's a lot to type in. You can, make mistakes, make errors. But there are your dimensions then. Okay. If we wanted to here, we could check to make sure that that 168 is, in fact, 8 maximum. If I go to my A prime and I put on my number line there 168.030, okay. If I check a number to the left, like 100, for example, and I plug it into the derivative, let's see right here, okay, 300 minus 100 minus pi over 2 times 100 plus pi over 4 times 100. We get a positive number, and if I go to the left there, I'll do like 200, I guess. So make these all 200s. And it's now negative on that side, so you can see that 168.030 is going to yield a maximum. Okay. So there you go.
Can you take a look at mine?
Yes. All right. Questions on any of that? Can you not do one of those? Well, we just did, so yes, we can do it. Ever again? We'll see.
Shut up, Brandon.
Find the dimensions of the corral. So the dimensions, I guess, I see what you're saying. I think with the way that we set it up, I think this is sufficient, though. We should be able to figure out whatever else we need. This is sufficient, I think. Because you have the diameter, you can find the rest now. All right, okay, so you're saying.
Sure, they give us some good money for that.
Yeah, they would. I'll figure out how much
You lost your minus 1.
What?
No. Yes. Your minus 1x there. Like, these do combine together, but minus 1x, they wouldn't combine because of the 5 pi. Like, that's got a pi. Like, these will...
Oh, I see what you're saying.
You combine the 1...
I combined it as if it was pi.
It's done.
Okay.
All right, let's try another one here. Okay, next. So we're not going to do a corral now. Yeah.
Oh.
Yes. Do you need right now? All right, I'll get you. Let me just finish right now, so I'll get you one.
Do you have an older brother?
Yeah. David.
Yeah, that's right.
Okay. A rectangular page is to contain 24 square inches of print. Okay. The margins, okay, at the top and bottom of the page are to be 1.5 inches. And to answer your question, Brittany, I didn't come up with this. It was in the book. Okay. And the margins on the left and right side are to be 1 inch. What should the dimensions of the page be? so that the least amount of paper is used. Okay, so question, yes?
What do you mean by, you mean the print is in like, so there's 24 square inches in the middle of the paper where you're going to be writing on it, and then the margin is 1 inch, 1.5, 1.5.
I think maybe a better way, rather than think about writing in the book, I think more like it's being printed, right?
Is there a
From
bug?
the ropes! That it's the entire page, is that? No.
It's still moving.
What is it?
It's like this, there's like this weird looking bug with like 15,000 legs.
Just got RKO'd from the ropes.
So like,
There was a cockroach.
And his name is John Cena.
So what the idea here, right, is that like when you go and buy a book, right, okay, the book has got, pages and stuff like that, and the pages, obviously, they don't print to the very edge of the page, they don't print from the very top down to the very bottom, right, there's spaces, there's margins, right, okay? Some of you guys, maybe when you're writing papers, have like messed with the margins, so that way it looks like you wrote more than you really did, kind of thing. But it's to make it look neat, and also I guess it's for the printer too. So that way, I guess it would have troubles maybe if it like went all the way to the edge or something like that. Okay, and so the idea here is that we have this rectangular page that needs to contain 24 square inches of print. So this, like, if you kind of take this, it kind of creates a rectangle right here, right around the print, and we want it to contain 24 square inches of print for whatever particular reason. That's our constraint here. Okay, so. We have these certain particular margins, 1.5 inch from the top and the bottom, but then only 1 inch from the left and the right. What should the dimensions of the page be so that the least amount of paper is used? Now you can imagine that would be a useful question, right? Because you need paper to produce the book, and so if you can use less paper, then that would result in the book costing you less, but then you can still sell it to the consumer for, whatever price you want. But it'll help reduce your costs. And of course, this book, for example, has like 100-some pages, but if you print 1,000 of these, you can imagine that saving that money would be helpful. Okay?
that's the kind of idea here.
So yes, exactly right. It's like a rectangle within a rectangle, and the two rectangles are going to be slightly different kind of rectangles, right? Because the one rectangle, like our page, the actual sheet of paper, okay? So let's actually just draw that. Okay, so let's say that's our page, but then within that we're going to have another rectangle that is not similar in the mathematical sense, okay, to it, because from one direction we're going to be going 1.5 inches from the top and bottom. The other direction from the left and right we're only going to come in 1 inch, so that it will not be exactly similar necessarily, okay? It won't have to necessarily be similar. So if I kind of let's see here, I'm going to kind of exaggerate this some so I can have plenty of space to label things. Yes, it's done. It's all done. I might be bringing it in tomorrow. Yeah, so I don't know if you guys know this, but you can actually use Word to print a book.
Yeah.
Did you know that? But I mean, it's not you think about it, and it's like, oh yeah, of course I can use Word to print a book. I can use Word to print papers, so why can't I print a book? But printing books is different because the way you fold the papers in half, and then you have to stuff a certain number of the papers together, and so it has to rearrange the pages so that it goes together right, and then you stuff that many pages, and then you stuff more pages, and you create this stack of pages basically.
It messed it up.
So the point is, so I put all those stacked together, and then you can I made a hardcover for a book. I bound the book, and then myself, and then I made a hardcover for the book too. So that's yes.
Is it abstract Star Wars fan fiction?
No, it's a gift for someone. So
is it really intimate?
So not
Okay,
well, it's boring. I mean, you guys probably would be. What's that? So right. So there's that one too. I have two of them.
Hey, what is your book about?
The book is just I took
Put it in the library.
I took Facebook messages and Gmails that I exchanged with my girlfriend and put them into a book.
So you're not an author.
So what's that?
I thought you were a legit
Well, I am the author. I wrote half of them, and she wrote the other half. What are you trying to say?
That's the way.
No, but you can so I then I bound the book, and I printed it, and I bound it, and I made a hardcover for it.
That is amazing.
So it turned out really good. I'm really excited about how it turned out. I was like, man, this looks nice. Not yet. No, soon.
Can we be there?
Oh, give it to her Valentine's Day.
I don't know if I want to wait that long because I'm so excited to give it to her.
Can I proofread it for you?
So we'll see. What's that?
Can I proofread it for
Can
you?
you proofread it?
Yeah.
It's not need to be proofread. The content is what it is. I don't want to change the content.
Yeah, but can we see that?
It's not exciting. You're going to be really bored by well, you guys, this is what you talked about. This is boring, kind of thing. So, no, sadly, she's ugly. And, but yeah, right. Yeah, no, exactly. She's got a really great personality, Mac. No, I'm just kidding. Of course, I think she's pretty.
Beautiful on the inside.
Do other people think
I'm gonna stop asking.
That's a good question. I don't know. No one in here has seen her. I
Put a
don't
picture on the
think.
projector. Wait, didn't she come in a white one?
You saw the carnival. There you go. Okay. So you can ask Brittany what her opinion is.
Bring her to one of our best ones.
Possibly.
Were you guys dating last year?
Yes. What month? Yeah, dark curly hair. Yeah. When was it? Yeah, probably then. Right.
Draw her on. Let's optimize this with girlfriend.
You should calculate the circle of the ring or whatever.
The circle of
I'm gonna maximize your enjoyment.
Take the diameter of her finger and the area and maximize how much metal, minimize the amount of metal needed to.
Right. Yes, because the precious metal, right?
Whatever.
Or what's the minimum size diamond that I have to buy in order for her to marry me? Let's figure that out, right? She works in a lab, so she's more sciencey.
Oh! This is like Mario here, man.
In some things, sure,
what
yes.
lab does she work in we'll decide.
Right.
Does she like chocolate cake?
Does she like chocolate cake?
Yeah.
I've
been
yes.
scratching super personal questions, so I wanted to.
Right. Yeah, I would imagine. Yes, chocolate cake. Yes, is something she would eat.
Does she like Star Wars?
She had not seen Star Wars before dating me. We watched the original trilogy. She liked those, and then she saw the newest one, and she really liked that one. She said. So.
She plays CS:GO.
No. Sadly, I'm working on that, but she.
Not that game.
She's like one of those. She's so new. She'll start playing, and she's one of those people that goes and then just starts around. She has no idea what's going on. You know what I'm talking about? And that's. She's never played before. She doesn't have brothers. She doesn't know video games.
I was going to say that's a really good idea for the book. That's really nice.
Thank you. Yes, I do have ideas about things. I do get some ideas.
There's more than math in there. Are there any?
What's that?
What's the book called?
Oh gosh. It's gosh.
You don't have to say it if you
I
don't want
called
to.
it Our Beginning.
This is just amazing.
And people are throwing up in their mouths. Are you guys throwing up in your mouths right now?
This is all on YouTube. Oh my god.
You
can show her this video after you give it to her.
Hey, I saw you in the park.
Yes, we're recording.
This is gonna get trending.
We met at church at a young adult group.
That was a long tangent.
It's like Christian Mingle.
Kind of.
White people be stuff.
Right, that's racist, right?
They have black people.
Right. My favorite mom, I was like, what's your favorite book of the Bible? Mine's Numbers. Can I have yours? Anyway, you like that one? Nothing. All right. Anyway, are we done now? Can we go back on track? We're good. All right. So.
Thank you for sharing with us.
Conversation.
You're welcome.
Should go on our cringe.
Is this all recorded right now?
I know. Yeah, our cringe. Right. Yeah. Exactly. It's been recording. Yeah. No one watches this, so.
I'm gonna watch.
Joe, you gotta check out minute 28. Mr. Wid, our beginning cringe. You asked. All right.
You're up on to watch it, and then the videos you're saying is just not attractive.
Sure, right, exactly.
You should just honestly just bring her in one day.
Show her like a show and tell kind of thing.
No, and then we're gonna kick you out, and then we're gonna ask her questions
About me? Oh, okay. Gotcha,
I
gotcha.
got the real Mr. Wade.
Right. Right, yeah, no, Mac's the one who asked all the questions. Right, yeah. Is Mr. Witt handsome?
No, I asked her Kissy about her, and I was like, is she pretty? She's like, yes, she's pretty. And then you never really know, because like you think she's pretty, but then like the real question is, do other people think she's pretty? Like,
Right.
Oh my gosh.
But does it matter though? If it's the person that you're dating, or
But I mean, like,
It's all relative, man.
No, but I feel like if she wasn't pretty, you might not talk to her, Like,
What are you talking about?
Stop
talking.
no, you have to be honest with the first thing that you know.
Sure,
is you
absolutely,
look at them,
absolutely.
and not look at somebody.
But there also are people I would say that you maybe wouldn't be attracted to physically when you first see them, but then upon getting to know them, you do get you find yourself more attractive.
Yeah, or like maybe they're pretty, but then they have a bad personality.
Right, which then, but people are more forgiving if they're pretty and they have a bad personality than the other way around, which is unwise. What's that? I'm not going to say.
What's her name?
No. And we stop there, okay? So, all right. You'll probably still be able to figure it out, but I'm not going to give it to you. All right, anyway, so
That's really creepy. Okay, let's
back
do the math.
on track, right, back on track.
Books, right? Yeah.
Yeah, what's your social security number?
What's your mother's maiden
What's
name?
your address?
Security number.
Right.
The tree grew up on.
What was your first?
Because I was going to look her up.
What's her first
I was going to
name?
Google
I
that.
need your blood type.
Right. All right. Woo, back
That was a good
on track here. No, she better not be X. A rectangular page, so we're all okay with this. So we have our picture right here. So 24 square inches of print is in this dotted line section. That's where the print's going to be. And we have this margin here where there will be no print, okay?
Big picture.
So okay, and so what we want to do then is come up with some way to represent this. Well, so we want to use the least amount of paper. So that means our primary equation is going to deal with the page, right? The area of the page. Now, we're not given any sort of guidance about the directions of these pages, or the dimensions of these pages. So let's just call it one of them X and one of them Y. So, what should the dimensions of the page be? The page, so that is the actual sheet of paper, so it's the outside. The dotted line, that section will be where the writing goes. So the primary equation here is just going to be A equals X times Y. Okay, that's that. But of course the problem here is that we have X's and Y's, right? So we need to come up with a secondary equation. All right, secondary. I don't know why I wrote the word secondary equation, right? Secondary, okay. So now, the only other piece of information that we have is that the area of this dotted line rectangle has to be what? 24. Yeah, 24 square inches. Okay, so we already know the area's got to be 24, but then how will we designate what the dimensions of that print space is?
1 times x minus 1.5.
No.
So careful.
Oh, yeah.
Right. It comes from both directions. So you have the right idea. That's good. So right, from the top and bottom, we're coming in 1.5. And so that's going to be then y minus 3 for the total. Okay.
No, wouldn't it be...
Yeah, 3.
Oh, it's
1.5.
yeah.
1.5, yep, plus 1.5. And then in from the left and right, we're going to come in 1 inch.
So it's 2.
And so, right, so it's x take away 2. So there is our secondary equation. Sorry, what do you mean why?
Like, wouldn't it be X? Because of the 3... Oh.
You okay?
Yeah.
Okay. So now we've got our secondary equation, and what do we do with that? Solve for one of the variables. In this case, does it matter which variable we solve for?
No.
No, you can pick either one. I'm going to go with x because that's what I did in my time I did it before. So we'll divide both sides by y minus 3. So it's 24 over y minus 3 equals x minus 2. And then we'll just add 2. So you get x equals 24 over y minus 3 plus 2, like that. Okay? And then once we have it solved for x, we now plug it in to the area. So we get area equals... Ooh, I don't know if I get myself enough room here. We'll see. I don't think so. 24 over y minus 3 plus 2 times y. All right. I'm going to, before we take the derivative here, what might be a good idea?
Carry the y.
Yeah, distribute that y. Simplify it some, okay? Right, we're not taking the derivative yet, so it becomes 24y over y minus 3 plus 2y.
Why? Because. Okay.
Okay. And now we have it simplified. I don't really think there's any other way we can simplify this, so now we'll take the derivative. So we get a prime equals, and we'll do the bottom, y minus 3 times the derivative of the top, 24 minus the top, 24y times the derivative of the bottom, all over the bottom squared. And then the derivative of 2y is just 2.
Couldn't you have also brought y minus 3 out of quantity to the -1?
You could have it and then done a product rule. That would have worked. It's up to you which one you feel more comfortable with. Do you prefer the product rule stuff? That's fine. Yep. It would be product rule and chain rule, but pretty easy chain rule. What Brandon was suggesting is make this y minus 3 to the -1 power.
No, I just wanted you to say
Oh. Sorry, I can't remember what do I normally say? Like the derivatives have layers. Okay, like that. Okay, there you go. Right. Chain.
All over now.
It's all over now.
Why did you do that? Like, how did you start to do that? Like,
Why? Because I watched the movie Shrek and I heard him say, ogres have layers, and then so. Oh, why did I start talking like him?
Like, how did you know you could talk like
Oh, because I originally did, you know the Austin Powers movies?
Yeah.
It's like Fat Bastard.
Yeah.
It's like the exact same, almost the exact same voice, and so I would do that because it was, you know,
That character
funny.
is hilarious.
And then if you watch So I Married an Axe Murderer, which is before Shrek and before Austin Powers, but still has Mike Myers in it, he plays his dad, who's like a Scottish guy. He like dresses up as his dad, and he like talks, you know, Scottish like that
You did the
too.
Russian dude for the play at the church.
Yes,
Oh.
you liked him. You like that? Yeah. So anyway, I do voices. I do voices. Anyway. So yeah. So now I have to solve this thing. Okay, we're going to set it equal to 0. I'm going to try and simplify the sum here too. So let's see here. I get 24y. 24 times 3 is 72. And then minus 24y. Okay, good question. Very good question here. The y minus 3, we cannot cancel out with the y minus 3 quantity squared because we have this subtraction here. Okay? So yeah, it kind of stinks. Okay, so real quick there for everyone to see. This y minus 3 does not cancel out with the y minus 3 down here. It's good that you're looking for that, but because we have that subtraction there, and this over here does not have y minus 3, we have to kind of leave it. So don't forget the plus 2 at the end, right? That's part of the problem. I'm kind of running out of space, so I'm going to have to go over to the side of my paper here. I'm going to do that. So I'll bring this up to here. Okay, so the 24 y's, though, what do? They cancel. That's really nice. And now that we've simplified it some, what can we do to start really solving this? Not add 2. Yeah, we'll subtract 2 from both sides. Right, you're like, oh, that's plus 2. And he's like, yes, it is, but what should we do to solve it? And that's right, okay. And then we'll multiply over the y minus 3 quantity squared. Okay.
And then divide.
Yeah, I would divide at this point both sides by -2 to get rid of that -2. So negative 72 divided by 2, -2 is 36. Ooh, that's nice. That's nice. So then what should we do now? Yeah, we can actually square root. We don't need to FOIL this out and then subtract over the 36 and then refactor. We can actually just square root both sides at this point. Yes, it does. We're left with y minus 3 equals plus or minus 6. Now here, we should be careful. We might be tempted to just throw out that minus 6, but there's still work to be done over here. So let's just check to make sure whether we should throw that out or not. So I'll put y minus 3 equals 6, and then y minus 3 equals -6. If I add the 3 over here, I get y equals 9. That's certainly, a possible answer. If I add the 3 here, I get y equals -3, so that's not a possible answer. We can't have a negative page dimension. So it's got to be the 9 there. Okay. If we end up with 2 y values, though, then we really need to go to our number line to check to make sure which one is going to be a minimum, the least amount of paper. Okay. But in this case, the 9 is going to have to end up being the minimum. It's like kind of so we ended up with 1 there. Okay. So we finally ended with 9 is y, and then how can we find our x? Because we want the dimensions. So you got to plug this 9 back in right here to our secondary equation where it's already solved. So it'll be 9 minus 3, 6. 24 divided by 6 is 4, plus 2 is 6. So x will be 6. And both these dimensions are in inches. So a 6 by 9 sheet of paper.
Cool.
6 by 9. So that's not a standard piece of paper there. Standard 8.5 by 11. By the way, true story, I don't know if you guys knew this, but like 8.5, 11 is not the standard sheet of paper that's used throughout the entire world. For example, you go to Europe, they use a different size called A4.
Yep.
It's narrower and a little bit taller than our page is, like in school and stuff like that. So it's so strange to go to a different country. Like, this paper is the wrong size.
That's American paper. That economic Chinese paper.
Oh, yeah?
Yeah, because all of them, I remember it because all
Oh, in middle school? Oh, in high school?
I think it was freshman.
Yeah, because all of the papers were higher than the binders.
Yeah, they didn't fit. Yeah, no, exactly right. Yes, there was a time they ordered the wrong thing, I think. It was probably really cheap. Like, oh my gosh, it's A4 this paper's really cheap. Let's get it. And it's it's the wrong size.
Probably they bought it from China or something.
Yeah, probably something like that.
So then in Europe, the binders smaller?
Yes, everything else is redesigned then to fit that. Yeah. Yep. Like their folders are different sizes because to fit the papers in and stuff like that. What's that?
We're the only ones that use it.
Oh, is that right?
Else in Canada.
Because it's in inches, probably. That's probably something. I think their pens are probably the same. All right, let me give you guys one to try here.
Really need some time to do my slate homework.
All right, this is the last one.
Yeah.
What is the radius of a cylindrical soda can So obviously we're approximating that a soda can is exactly a cylinder because you have the beveled edge on top and the beveled edge on the bottom. But
What's that word on the left?
What's the word for the?
Yeah.
what is the radius?
We can't. It's not on the.
Oh, I see what you're saying. My mistake. What is the radius of a cylindrical soda can with volume
What?
of 512 cubic inches? Which I know is still, you wouldn't ever measure soda in cubic inches. It would be in milliliters, which is cubic centimeters, but anyway. That will, or cubic millimeters. Is a milliliter, I think. That will use the minimum amount, right, of material. And of course, the material, we're going to judge the amount of material we need by the surface area of the can. So let me give you two formulas you're going to need here. The volume of a cylinder is pi r squared h. And the surface area of a cylinder, well, a cylinder is made up of kind of three shapes, I guess. Two circles on the top and the bottom, so 2 pi r squareds, plus then a rectangle that's kind of wrapped around them, okay, which the rectangle's one measurement will be the height, but then it'll be also the circumference. So it's 2 pi r h. Okay, so there's your surface area and volume formula. So go ahead and give that a go. So you want to find the minimum amount of material necessary. What's that?
That's the volume of cylinder, right?
For the minimum amount of material?
The first equation is the volume of cylinder.
Oh, yeah, volume of cylinder. Yeah, the first equation is volume of cylinder. There's testing.
No, it's Park still.
I don't know actually. I think HSA maybe next week, or maybe HSA is today and Park is next week. I forget.
No,
One is happening.
Park's today.
Okay.
Just algebra 1.
I think so, yes.
That's when you have to solve the variable.
Did you guys take Park yesterday? Like the second multiple choice part? I thought yesterday was way easier than the day before.
Some people are really easy.
To be quite honest with you. The day before I didn't think it was too bad. Just some of the readings were like, I was so tired.
Yeah, I was like, towards the end of the test, I don't want to do it anymore.
Yeah, that's why I was like, I was kind of like the last one I was like, yesterday I thought it was super easy.
H equals 512. V is 512.
Oh, you we only have 2 variables.
I do have the answer for this one if you're like wondering whether you got it right or not. Yes, 2 pi r h.
Would this be a calculator problem?
Wouldn't, I mean, again,
You don't have to.
calculator's not necessary,
Yeah.
no. So no, it wouldn't have to be. Would not have to be. Again, all I'm asking here for, folks, is the radius of the cylindrical soda can. Now, of course, yes, yeah, you would have to do it that way anyways. Yep.
Michael Geiger wants human beings. I don't know, mine's still pretty frigid in here.
I mean, this is bearable. This is much better than it was earlier.
Oh, because you were responding.
Yeah, it was just me.
So 2 pi r, before I take the derivative here, I would multiply this through it.
You don't have to, you can't use a calculator.
So for example, the pi's will cancel, because you have a pi in the numerator, pi in the denominator, so the pi's will cancel. You have a pi opposed in 1024, and then the r, if you cancel one of the r's here with that r squared. So simplify first, and then go.
Yeah. Okay, so I got it down to this, which I'm pretty sure is right.
Okay.
Can I use a calculator to like? I think it could work out nicely to like. I would need a calculator.
Well, just continue. Wait a minute.
So I would divide by 2 pi.
Something something's negative and it shouldn't be.
Because I subtracted over the 2 pi r.
Right. Now I see what you're saying. Oh. When did you take the derivative?
I didn't yet.
So you shouldn't set equal to 0 then. You only take set equal to 0 after taking the derivative, right?
What's the thing kind of maximum on? So that would be the minimize of the surface area, right? So SA equals 2 pi r squared plus 2 pi r h. That's the thing you're trying to minimize. The problem is that formula has an r and h, 2 variables. So you then use your secondary equation, which is volume. You know what the volume has to be. 512.
Minus.
You need to then manipulate that volume equation, solving for I would say H, that's the easiest, and then plug in for the H, the other equation, right? That's the whole point of having a secondary equation, so you can plug it in. That's what you should do. I'm sorry?
How do you find the radius?
For what?
For this plug
You're not gonna plug in, you have an H. You're gonna plug this H1 in for this. You take the derivative with respect to R, and then, yeah.
Okay. So I got it down to something very...
Because, Emma, that's also what you're looking for to do eventually, right? What is the radius? So that's what you're trying to
I got it down to something almost identical, just without the negative.
Okay, so
So
divide
can I use
3 by 4 pi then. But, so do you need a calculator? The answer is no, because you can remember, you don't have to simplify arithmetic. So you can just leave it unsimplified is all. So yeah, just like what he's got. Cube root of 1024 over 4 pi. That's sufficient, but of course, you can use a calculator to simplify it.
Okay.
Shoot out that
So then when we oh yeah, that's the radius. Cool. Is that the correct answer?
Yes.
So these are typically pretty messy in terms of
They take some,
value.
The more complicated the situation gets, the more, work it requires.
And then times by.
Okay, I'm taking the picture again.
No, keep going.
Alright.
No, wait. Emma. 12 likes. Oh, never mind. Picture's gone. Yeah, I got a screenshot.
What's the cube root?
It's the derivative.
Why divided by 4? Oh, but you're actually going to
Like the derivative of 2.
Yeah, no, he's simplifying it before he cubes the cube root, which makes sense.
Yeah.
Oh, you're right.
Alright, how do I do this?
Okay. Pick a clock that you like. Doesn't matter. One that you think is kind of cool.
We're almost there.
Okay.
We're going to work through this.
So what did you...
After this, it's just homework, correct, Mr. Wood?
Yeah,
I got
so
the
if you want to do your psychology or whatever you have to do.
That's okay.
4.335.
The one that I like is
I didn't know, like I
Elegante or Elegant.
math.
I think that's kind of cool. Like cursive.
You're trying to solve it.
There's also like
I like the...
And I just put in the answer. Yeah, 335.
this one.
Rounded, that's okay. Just truncated.
Okay. So I like that one. So is it cool from one data? Does that matter?
Actually, read the directions.
No, that's it. We got the answer, that's right.
It's not. It's not.
Now, can we see if that's the right answer? or-
1.225?
Yeah.
Oops. No, I don't
What
know.
the direction asks for, what is the radius?
You get so far in this problem, you just want to go.
I was gonna keep going.
Yeah.
Right, that's why it's so
Okay, do you want to use the same background or do you need
Question, and make sure you're But understand, when you give the extra information, they say that extra.
What?
You take the derivative and simplify, or do you simplify and take the derivative?
Simplify and take the derivative.
Yes, they can,
Okay, I got it.
you're not showing that you're understanding what's being asked.
So, would you go this?
Okay, so,
I'm with my, I'm gonna do this.
Okay.
Just, you're right.
So 1 times r squared over 1 is our cube. dividing a negative 1024 over would not yield a 0, so 1 here.
Yeah, don't do that.
Right. Yeah, that's what you're like, how do you multiply those? Okay, so when you multiply that circle, it's not 0, you get 1.
Right.
1 multiplied by 1. And then you solve from there. Yeah. Like this is R by itself. You kind of did a little bit more than you need to do. You really, what I would suggest is small multiply by R squared. You get the R squared out of the denominator, multiply that, and then you get R.
Do you want an icon theme?
Simplify.
Do you like a minimal one or do you
Cancel,
like
the R here can cancel, 2.
Yeah, just like the white ones,
You can do that math. I think you'll find it easier.
There's some other cool ones you like.
Yeah, I'll look for them.
I just like this. There's some good ones. The one that I have is.
Yes, absolutely. Yes, that was good.
Good job.
I'll take this one. What is that? Okay. Yeah, so just install that.
Y'all do no pain reviews. So you're not doing it. You're just confused. My job is. I just don't understand this math right now, but that's okay.
I have Leslie and Mara here.
Oh, I would suggest not.
What the? Okay, so is it installed? Yeah. So let me see first. So,
This is a negative 1024, right? Why don't you consider.
Awesome.
Derivative and you. So that's positive 1024 over R squared over here. R squared over, so you have R cubed.
okay, so do you want to like have your phone like this now? Yeah, sure. Alright, always. Do you want to change it?
In this case, Connie, yes,
You
yes,
have
not
all
the
the
way you want to go.
icons
That
in
would be, I think,
So we're going to need to change the app door color.
Yeah.
So door after, we'll make it 6 by 5.
Correct, but you could rewrite over R as R
No,
to
the background.
negative 1.
Clear.
So 2 pi R squared?
Now just grab whatever icons you want onto the home screen, but let me set up
2 out, 2 R. Yeah, exactly. 2 pi is the coefficient.
I don't know if like I have like, I don't know why, but he just carries the moment.
Yeah, no, so I get why that's confusing. You see pi, like that's not a number, that looks like a variable or something. It's not, it's just a number. So yeah, it'll become 4 pi R is all that becomes.
It's a lot of apps.
I think you got jealous.
There we go. That one.
Yeah, my cat, whenever we have to have a he usually gets jealous.
Oh, I see that change.
Just like you said.
Yeah. Okay, so now just put whatever icons you want, and wherever you want them. And then you can add more pages if you like.
A lot louder than
I'm gonna make a copy of the practice test for you, so that way you can have something to kind of like look at.
Alright folks, like I'm gonna come back in 1 minute, I'm gonna go make a copy real quick for Caleb. We'll go over this problem in like 1 minute, so be right back.
Can I make this bigger? What? The icons? You have to buy the app for that. You can make the grid bigger if you want. So if you go to like desktop and then desktop grid, you can make it bigger. So by making it bigger, you're gonna make the grid smaller.
I only have like blue stuff and I can't wear, I have to wear this. I'm not gonna wear a scarf. I got like 4.324. Oh yeah.
Oh, that's what I got.
This meat can be a joke for putting all this stuff in the
And like I'm so many except I'm swimming 100 flies.
You're asking how old you are.
Like it's TJ. Because he beat me by 0.2 seconds. That's the time we raced. And I'm better than such pounds and
How old was Smokey when you
they have like 5 days, we have 18.
For a big dog,
They literally can't see them. They come in person at every event.
Pretty much whoever has the most kids wins.
Big dog, like,
Wow. Well, but like if it's like 18 kids and 15
4.33
kids, it's close. And there's like 18 and 15
Yeah,
kids,
but
it's
the
close.
more kids you have, the
Brunswick anyway. Brunswick's on anyway.
we got
It's like
the ones who don't pay attention.
Did you make your grid an odd number?
Yeah.
Oh, yeah.
Good luck reading it.
So,
You have to make it an odd number.
You might want
Those are settings of
And then I will have an
Hold down
ASCII for
the-
all of them up to number 20, and then for some reason I didn't have 21, 22, 23, but I think I know why. Alright. Done, any question?
retriever or not. Number 3.
Yes.
There was a breeder.
4.25. Alright, so folks, let me show you here. Alright, this is what you should end up with, 4.335 inches, okay? All you had to do was find the radius here, so there was no need to find the height. If you did, that's fine, but understand the directions only asked for us to find the radius, so we didn't need to find that height. Okay?
Yeah.
Any questions on that?
Don't you divide that by negative 4? Or 4?
If you actually
Oh.
you plug it into your calculator.
Oh, so yeah, I had 256, I was like, you were 256 over.
Oh, okay, yeah.
But it's not even.
It should be. Make sure you type it in correctly. It should be the same thing.
Divide by 5.
There you go. All right, so, Connor.
I did the last one, we got 5.299.
If you just plug that straight in, that's what you get.
Did you have this value though?
Yeah, 1,024
Into the cube root of that.
And then hit F door.
And I put in parentheses too.
I'll come take a look at that in a second.
It's what it came up
Let me-
on my calculator.
Let me give you guys an assignment here real quick. Okay. Don't have time. We do have time. We have just enough time. I'm sorry I talked for so long.
You're fine.